Hello, everyone. I'm Nathan Trueblood, VP of Product Management from DataTorrent. And first of all, welcome and thanks everybody for joining our webinar today. Over the next hour or so, I'm going to talk a little bit about DataTorrent and real-time analytics. So we'll give a little bit of an orientation on our company and product. And then we'll get into talking a little bit about our Omni-Channel fraud prevention application. I'll do a demonstration, and then at the end, we'll do a little bit of a look under the covers and see how the application works. As a matter of housekeeping, please hold your questions until the end. So go ahead and raise your questions using the GoToWebinar app. But we'll take those at the end, and we'll do our best to answer all your questions in the remaining time. And for any questions that we can't answer, we'll follow up afterwards with an email and do our best to answer all of your questions. So let's go ahead and get started. So first of all, a little bit about what we're seeing in the market in big data. We're really seeing a big shift in big data processing. The world of sort of processing data at rest using traditional ETL and batch processes, it isn't going away, but it's really giving rise to a whole new approach to processing big data. There's really, what we're seeing in the market today is constant pressure to produce decision-ready data and really to produce insight and decision-making faster. In fact, many of us at DataTorrent came out of sort of the early days of big data where once we were able to process huge volumes of data and produce insight, then the pressure was always, can we produce that data faster? Can we produce insight from large volumes of data, in an hour or in a few minutes? And nowadays, those timeframes are down into sort of the speed of machines and under 100 milliseconds and so forth. So, there's this big pressure and shift to produce insight from large amounts of data more quickly, and at the same time, businesses need to control both the costs of developing applications that take advantage of that technology, as well as the ongoing operational costs, what it takes to operate fast data analytic applications. So as a result of this pressure and sort of market shift, a whole new architecture is needed, and that's what DataTorrent and our product and really the Omni-Channel fraud prevention application is all about. So we'll get into the details in a few minutes, but really a new architecture is needed for producing insight from big data quickly. We're moving from a world where you produce insight after the data has landed on the hard drive to a world where you're looking to produce analytics and insight and decision making before the data even lands on the disk drive, before it even lands in your cluster. So we're moving from a world of data at rest to a data in motion, and we're also moving from a world where everything was sort of done on premises to a world where you need to be able to process large amounts of data with low latency on premises and in the cloud and so forth. So there's a big shift happening that we're seeing, particularly in the last year or two, around moving from traditional to more real-time big data processing. So what's the reason for this? The real reason that we see here at DataTorrent is that our customers are learning how to shrink the time between when data is created and when they're able to produce insight and take action from that data. So we're moving into a world of real time, not that batch-based processing is going away, but that more and more our customers are coming to us and seeing how the ability to produce insight from data the moment it's created is a huge competitive advantage. And we'll get into this in a few minutes when we talk about omni-channel fraud, but really when you map this to something like fraud prevention, the ability to produce insight and detect and prevent fraud before it happens is a huge competitive advantage for DataTorrent's customers. So a little bit about our product. I'll explain a little bit of the product architecture, and then in a few minutes we'll get into a demonstration. So DataTorrent RTS is an in-memory stream-based analytic processing system. So what does that mean? It means we take data in at large volume with fault tolerance and produce insight and action from it. DataTorrent is based on the Apache Apex project. Apache Apex is a stream processing abstraction. It's a stream processing engine that runs on top of Hadoop Yarn. So we use Hadoop Yarn really as the resource manager that manages all the computing and memory and storage resources that are required for streaming analytic applications. So Apex runs on top of Hadoop Yarn, and we can deploy DataTorrent on premises against Hadoop, or really against any popular Hadoop distribution, both on premises as well as on AWS, on Azure, and on Google Cloud Platform. So Apache Apex provides the abstraction that allows you to express an analytical pipeline, meaning an application that can take in data and produce analysis from it. At the top of this picture, you see sort of a simple example of an analytical application where you ingest, you transform, you produce analytics, and you alert on the basis of that data and then visualize and persist it. So Apache Apex provides that abstraction, and then DataTorrent on top of Apache Apex, together with our open source community, produces a whole library of input, output, transformational, and analytical operators that allow you to quickly create streaming analytic applications. So these operators, you can think of like building blocks as a way to quickly assemble an analytical application. Now, a powerful abstraction, as in Apex, and the set of building blocks, it certainly helps our customers and developers produce applications. But really, our product is focused around all the things you need to be able to take those applications, develop them quickly, and put them into production. So I'll show this in a few minutes when we get to the demonstration, but DataTorrent RTS provides all the management, the monitoring, the real-time visualizations, and so forth that you need to put streaming analytic applications into production at scale. Now, an abstraction and building blocks are helpful, but we've taken it even further. More and more, when we look at the complexity of big data applications, our customers are looking for ways to shorten the time to getting an outcome from their big data projects. And so as a result, we are starting now to offer pre-built real-time analytic applications. And so we'll give an example of one of those in a few minutes. But increasingly, what we're doing is delivering pre-built applications that help our customers very quickly get to an outcome and get value out of their investment into big data. So a few examples of where we're working today, and then we'll zoom in on fraud prevention. So today, as I mentioned earlier, customers more and more are seeing how the ability to produce insight from data is making them more competitive. It really comes down to the more responsive I am to changing business conditions, the more responsive I am to my customer, the more competitive I am. And I think that's a big reason why we're seeing a lot of interest in real-time analytics across all these different industries. And so, today we're focused on financial services in, fraud and risk prevention, but we also have applications in advertising technology and telecom, and so forth. So I won't read this slide to you, but the fact that we're seeing such strong interest in real-time data processing and analytics across all these different verticals would seem to suggest there's a big market shift happening in big data from not just processing data at rest, but processing data at rest combined with data in motion for maximum value. So as I mentioned, one of the ways that we're focused at DataTorrent on helping our customers get to outcomes quickly is not only have we produced a very powerful platform for developing streaming analytic applications, but increasingly now we're offering pre-built applications such as Omni-Channel fraud prevention, but we have a whole marketplace in our product of various different pre-built templates and applications that help you quickly get started and get to an outcome. Most developers don't start with a blank piece of paper. Most of us start with someone else's code or project or sample or template as a starting place. And so DataTorrent created the application factory as a way to help our customers shorten their time to value and get to an outcome as quickly as possible by providing an application that can be a foundation for solving a business problem. So let me get into Omni-Channel fraud prevention. This is an example of one of the AppFactory applications that's available in DataTorrent RTS today. So why fraud? So we chose omni-channel fraud prevention as an application in our AppFactory for a number of reasons. So first and foremost, fraud, and in particular omni-channel fraud, is a huge and growing problem. It's not well served by today's technologies. There are very rich and extensive anti-fraud applications, but at the heart of the problem, you have the challenge of how do you take in all of the data, analyze it, and make a decision about whether or not something is fraudulent or not in a time frame that's going to matter. So, today's fraudsters are getting more and more sophisticated. The amount of data and the number of different ways that they're committing fraud is increasing, and so we see this as a huge problem. And in fact, we've worked with other customers in DataTorrent's history in producing custom anti-fraud and risk management solutions for them. And now our omni-channel fraud prevention application really represents sort of the best practices and what we've seen with our existing customers in what it takes to handle the data volume and the latency problem of fraud prevention. So in this application that I'm going to show you today, really where we're focused is not on everything that you need to do to manage fraud, but really on the hardest and most crucial part of the problem, which is providing a platform and an application that can take in and handle all of the transactions and produce decisions on those transactions in real time. So this is moving from a world where you simply detect fraud and then later on try to prevent future instances of that fraud, in a world where you can take in all the data and analyze it and make a decision on it in a short enough time frame. You can prevent all of the fraud before it happens, or at least that's the goal. So in the application I'll show you in just a moment, we've built an application that can handle all the volume, provides the ability to handle transactions from across multiple channels. And by omni-channel, we mean point of sale, web, mobile, and so forth. So their customers are shopping across multiple different channels and making transactions in those channels, and that actually increases the opportunity for fraud, where the bad guys can exploit making transactions across those different channels. Now with DataTorrent's omni-channel fraud prevention application, we can prevent those kinds of frauds from occurring. So a few other things I'll point out in the application. So we can handle all the volume with fault tolerance in a time frame that matters. We've also introduced, along with this application, a scalable rules engine, which is really the heart of what you need to be able to look at a transaction and make a decision about a fraud in real time. But enough of the slides. Let me get into a demo and do some showing as an example. All right, so what we're looking at here is DataTorrent's RTS. So this is our user interface, our console. And what you're looking at here is actually where a lot of our customers get started, which is the application factory. So this is what I was talking about earlier, where not only do we provide a powerful platform for developing fast data applications, but also we have a whole marketplace and library of applications and components that can help you develop applications on your own. So for example, we'll talk a little bit in a minute about our fraud prevention application, but from within the product, this is something you can go in, browse, look at all the various different applications and use cases that we can solve, and then from within the AppFactory, click on a particular application, and then this application can be downloaded directly into DataTorrent RTS, where you can then configure it or start extending the application for integration in your particular enterprise environment. So the AppFactory makes it easy to see what's possible for your business, and we make that even easier by providing applications that get you there. So if I click on the Omni-Channel Fraud Prevention application, there's a lot of the technical details of how this works, and this same information is available on our website as well. And then from here I can go ahead and download it. Now, to save time for the webinar today, I've already downloaded the application, so let's take a look at that over here. So I've already downloaded the Omni-Channel Fraud Prevention application into the DataTorrent RTS console, and I can see a variety of other applications that have also been downloaded here. For example, we have other applications in the AppFactory for simple functions like the ability to ingest data at large volume into your data lake and so forth. But the one we're going to look at today is the Omni-Channel Fraud Prevention app. And I can see here from the console of the ones that I've downloaded, I've already got an instance running on my big data cluster. So let's take a look at this. So what we're looking at here is the DataTorrent console. And this is really what a developer and DevOps person would use to really understand what is the operational state of my fraud application. So they really use this to both develop the application, tune it, and optimize it, and operate these applications in production. So what we can see in this view is the fundamental view is we can see this processing pipeline. Essentially, a pipeline takes in events, transactions, and then produces answers about whether those transactions are fraudulent or not at the other end of the pipe. So if we look for just a moment at what this application is doing, we're taking in transactions at volume across multiple channels here. We're parsing them, validating them, and ultimately what we're trying to do is look at a particular transaction and make it decision ready. So we enrich that transaction with who is the card user of this particular transaction, what card products were involved, what geography was this transaction taking place, what products were involved in the purchase. So this pipeline, as I said earlier, is all about taking that small amount of transaction data, enriching it with everything we know within our enterprise about that transaction, so that it can then be passed through a scalable rules engine, which allows us to then make a decision about whether or not a particular transaction is fraudulent or not. And so once that decision is made at this stage, then further events are fired off to let the fraud analysis team know that fraud has been detected or prevented, or just to simply flag a worrisome condition that may require further investigation. But it's all about take in volume at scale and pass it in a scalable way through a rules engine. Now, this simple logical view that we're looking at here obscures the fact that behind each one of these stages, we're running on top of a large-scale compute cluster. There's a lot of computers behind this, and so to handle the volume, each one of these stages can scale independently on the cluster to handle the processing volume and ensure that we're able to detect and prevent fraud within a time frame that's going to matter. And so, in fact, when I look at this application overall, I can see how much data volume, and I can also see how much latency is involved in the overall end-to-end processing. So now this application is useful for, this view in our application is useful for a developer, an architect, a DevOps person. But in addition to the application itself, it also comes with a number of pre-built visualizations that make it easy for you to understand how well is this application working. Is it solving the problem that it's supposed to solve? And are there things we need to do to tune this application so that we're getting the most benefit from it? So, for example, right here from the app, I can go to a number of pre-built dashboards that come with this application. So when you download our Omni-Channel Fraud application, all these dashboards and visualizations are included. So, for example, I can take a look at the fraud prevention summary. And this just gives me a high-level view of how my fraud application is doing at the moment. For some reason, this one's rendering slow, so I'll switch to this one that already rendered. So what we're looking at here is a summary of what's going on in real time in the application. So at a high level, we're seeing what is the total amount of fraud prevented in the last minute, what are the total number of instances of fraud we're seeing, and as the transactions flow through, we can get some idea of what is the percentage of fraud caught within a tolerance. Now it looks like for some reason this isn't updating, but I'll walk you through. Let me just quickly check here and make sure I haven't lost my connection. No, looks good. All right, so to continue through the dashboard, so just this is a high-level summary that shows roughly the total volume and where we're seeing fraud by channel. And furthermore, we can also get a view here of where is the fraud occurring. Now, of course, this is a demo for the webinar, so All of this data is manufactured data, so naturally, since we're in San Jose, California, all the bad guys and the transactions are coming from San Jose. But this gives you an idea of sort of a summary view of what this application is doing, and we can see things like what are the cities and so forth that are producing the most fraud. Now, in addition to this particular visualization, I can also look at some deeper analysis of what's going on. So, for example, I can see the total amount of fraud prevented in the last minute. Again, same as we saw before. But then we can dig a little deeper in this view into what's the total transaction volume in terms of dollars, what's the transaction volume in terms of events, and start to dig a little deeper into what kinds of devices are we seeing where the fraud is taking place. And when we talk about applying rules to fraud prevention, this gives me an idea of which rules are producing the most hits from a fraud prevention perspective and which ones are producing the least hits. Now, in our omni-channel fraud prevention application, we provide a sort of simple set of initial rules, but our experience with customers is that every customer has a set of fraud detection and prevention rules that they need to implement. So our application comes with a simple set of rules, but we expect our customers to extend this. And this dashboard really helps our customers see which rules are producing the most hits and is this application working as expected. So now the last dashboard I'll show you here is really more of a technical operations view, where, as I mentioned, in this application we're showing a scalable rules engine, and really to me a rules engine is just part of the overall decision engine that needs to be put into an application like this. And when I say decision engine, I mean most of our customers today are fighting fraud with both a combination of rules as well as machine learning based algorithms. So to really do fraud prevention, you need both a scalable rule engine as well as machine learning algorithms. So what we're looking at here is a dashboard that is helping us understand how well is that rule engine really working. And so, for example, we can instrument this application to understand things like what's the latency of rule execution. Why does latency matter? Because it really comes down to we have to be able to make a decision about a transaction in a time period that's going to matter, and that's typically under a couple hundred milliseconds if we're going to be able to see a transaction, flag it for fraud, and make a decision about it, and still be able to produce a good customer experience. So rule execution latency is really important from a technical operations perspective, and so this dashboard is here to provide all of those details, including things like what kind of process failures are we seeing in the big data cluster and so forth. Now I should mention the application comes with all of these dashboards that we've put together to give you both business and operational insight into how well the fraud prevention application is working. Each of these dashboards is super easy to extend and modify for your own purposes. So for example, it's easy for me to edit this dashboard and add a widget and collect more statistics from the application and display them here. So we make it really easy, essentially to create whatever instrumentation you need to be able to put these applications into production. Now, to be clear, the visualizations you see in DataTorrent, these are all real-time visualizations. So we're not trying to replace Tableau. We expect most of our customers have something like Tableau and other things for visualizing historical data. What these dashboards and visualizations are for is really providing you that real-time insight into how well is the application working so that you can understand its operational state. So with that, this gives you a pretty good idea of how DataTorrent works. You can go to our AppFactory, you can download our applications and app templates, you can launch them, you can monitor them in our console, and for any given application, if it has dashboards already from us, great, you can also create them yourselves. Now, I'm showing you a prepackaged application, but of course, DataTorrent RTS is designed to make it really easy to develop your own applications as well. We're just shortening the time it takes for you to get value out of real-time analytics by providing out-of-the-box applications like our Omni-Channel fraud prevention app. So let me go back to the presentation and share a little bit about how it works and what's going on underneath. All right, so what did we just see? So in our fraud application, what we saw is a demo of how we can take in all of these transactions. They're typically coming in from a whole variety of sources and ultimately being passed to us via a message bus, in this case Kafka. We ingest that data, we enrich it with what we know historically, and quite often along the way, when we're taking in that data and enriching it with historical data, we often will also emit that data back out to persist it in a data lake. And that data lake is there for historical analysis as well as for the production of machine learning based models. But what we looked at today was how in a typical fraud prevention application you have both a combination of a scalable rules engine as well as in some cases a machine learning based model. But we're focused on the fraud rule execution, so that's the part we just saw. And once the transaction goes through, we then pass that, trigger other parts of the organization that fraud has been detected or prevented. We provide analytics so you can understand what's going on in the application. And ultimately, those alerts and triggers for fraud also have to be persisted back down to some kind of data lake for compliance and historical analysis. Now, in this application that we shared today, we talked a fair amount about rules and rule engine. So why the focus there? So really, when we talk to our customers and look at the overall challenge of fraud prevention, there's a lot of discussion in the marketplace right now, and we're certainly involved in these implementations as well, but there's a lot of enthusiasm and energy, of course, around artificial intelligence and machine learning and machine scoring and so forth. However, when you look at the fraud prevention problem, really the majority of fraud is sort of crimes of opportunity, and so that's where the rule engine is required to be able to handle, frankly, the majority of the fraud cases. Quite often what we've seen with our customers is just simply being able to process all the volume and apply all of the rules and still be able to have that take place in a very short time frame is a huge challenge. And so what we looked at today is how we're focused on the biggest impact, at least in this application, which is a scalable rules engine. But of course, our application can easily be extended with a machine learning based model that's trained on data you have within your enterprise. So you need both rules, and eventually you also need machine learning models as well. So this application can form a foundation for that. So a little bit about the rules engine. So the rules engine that we built into this application, that's one of those building blocks I talked about earlier when I was going over our product in general. We've taken the popular open source project Drools, which is really a project that's been around for a while for expressing business rules in a fairly easy way. So Drools is something we took and adapted for data in motion, low latency, and scalability. So Drools in and of itself makes it really easy to express a set of rules for some kind of complex event processing. In this case, we're talking about fraud prevention. But Drools in itself doesn't scale. So we adapted it to DataTorrent, made it scale, made it fault tolerant, and made it able to handle the volume. So now we have a rule engine that can be applied to all the transactions at volume, but also supports dynamic rule updates and so forth. So we've made it really easy to express the rules, to scale them in processing the data, and then of course Drools also comes with a workbench capability that makes it easy for fraud analysts to be able to edit the rules and test them and so forth before pushing into your production fraud application. So that's just a little bit about what's going on in the rules engine. So, for example, and I won't go into too much detail here, these are some examples of, the kinds of rules that we support. We support both stateless and stateful rules, where a stateful rule is something like looking at whether or not a transaction has happened across, for example, 3 different disparate geographic locations, but in a very short period of time, for example. So Drool supports, easy way to express rules as well as decision tables. And so, we chose this because it's very popular and easy for analysts and developers to be able to express the kinds of anti-fraud measures. And as I said before, our application comes with a sample set of rules, but we would expect all of our customers would take these and then extend them. So now, as I kind of hinted earlier, beyond rules, what we do with our customers today is, so we've taken in the challenge of being able to provide a scalable rules engine for analyzing all the transactions and producing insight and making this decision quickly. But then in addition to that, we're working with our customers today to operationalize what they're doing with machine learning. And the reason I point this out is that there's no single common agreed upon approach for machine learning or AI-based technologies today. So what we do is we provide a platform that enables production-ready analytic applications, and then we work with our customers to take the models they've developed and trained based on the data that they have on customers. We then help them to operationalize that into a streaming analytic application. So if you remember the picture I showed a few minutes ago with the transactions flowing from left to right, to really do fraud prevention completely, we can help customers who are innovating with machine learning to take our basic application and extend it with machine learning technology as well. So, the innovation is happening in machine learning, but in order to harness that innovation, our customers are working with DataTorrent to put machine learning into production at scale using the Omni-Channel fraud application as a foundation. So as far as where we're going next, coming up soon, in the next few months, we'll be releasing a number of interesting things. One is, we're not just stopping with payment card or omni-channel transaction fraud prevention. We'll also be offering other applications in the AppFactory, again, based on best practices we've learned from our customers. So coming up, we'll have an account takeover detection and prevention application, which essentially is aimed at preventing fraudsters from getting into your accounts, taking it over, and then committing fraud. So that application will be out in a few months' time. And I should mention, although DataTorrent, our RTS, our product, only comes out maybe every quarter or so, we are publishing new content via the AppFactory. New applications get refreshed more frequently. So our account takeover application should be out pretty soon, and we're also working on, of course, the next version of our omni-channel fraud prevention application. As we get feedback from customers, as we learn how to do things better, we publish updated versions to the AppFactory and make that available to our customers. Now, one of the important things about our account takeover application that's coming up next is when you run multiple applications on DataTorrent RTS, you have the ability for those applications to communicate with each other. So while account takeover might be handled by a different team or a different department within your company from, for example, transaction fraud prevention, by having multiple applications running on the same platform, they can signal each other. And this is what's meant over on the right by the multi-app information bus. Essentially, multiple anti-fraud applications can be running on DataTorrent, and when, for example, you see an account takeover event in one application, you can signal that event to the transaction fraud prevention application to let it know that a particular customer or account has been hacked, and so you can flag those transactions. So that essentially means the more applications you put on the platform, they're going to contribute to each other and provide a more complete overall fraud prevention solution. So a few of the other things that are coming up, we're working on providing out-of-the-box machine scoring support. I talked about that a little bit earlier. One of the other things that we're working on and will be coming up in our next release is a little bit more fine-grained what-if analysis. The customers we talk to are constantly trying to understand, are my anti-fraud measures working? Are they working as expected? Or, if I had changed my rules or changed my model, could I have done a better job in preventing a fraud event that happened in the past? So we're adding capability that makes it easier and easier to replay historical data and compare the results from one fraud application versus another. So this would allow you to compare rule sets or models and be able to essentially evaluate, is the new version, is the new model producing the results that I'm expecting. If you recall from the demo I shared earlier, we had a lot of dashboards that allowed you to sort of get some operational insight into what's going on in those applications. Well, combine that with what-if analysis, and now you can replay data and be able to compare and see, are the new measures working as expected? Are they more effective as we hoped? And then, of course, we're extending the DataTorrent platform to provide a little bit more ability to drill down into historical data. This is really about exploring a particular fraud event, being able to zoom into some of the historical data. Our anti-fraud application is really focused on sort of the production operations side of things, which is processing data in real time and memory. We're extending that with historical drill down and the ability to do sort of what if and slicing and dicing of the transaction data, again, so that analysts can get a better understanding of how to improve their anti-fraud measures. So that's what's coming up a little bit in the roadmap. So with that, I want to point out some resources that are available to you. So we're just about at the end of the webinar, and we'll do some Q&A in just a moment. So some resources available to you. We can send this out as well later, but certainly you can read about some of the applications we have available in our AppFactory. You can download a sandbox version of our environment. So there's all kinds of ways to engage with us and learn more about how we can potentially help and collaborate. So we'll send this out later, but there's all kinds of ways to engage with DataTorrent. So with that, I'm not going to stop yet. I want to do some Q&A. So let's go to, let me change my view here and see some examples. So one of the questions here is about, can we show an example to risk alert? So because we're dealing with transactions at volume, we don't typically demonstrate sort of what happens to one individual transactions, because we're dealing in many cases with hundreds of thousands of transaction events per second, so it's hard to visualize. But for example, what we typically do is when a fraud alert takes place, there's a couple of things that happen. One is when a transaction is flagged as fraudulent, that can be emitted back out onto a Kafka message queue to alert, for example, a case management system or any other downstream systems that need to act on the basis of that fraud prevention. We also have other operators that can be used to extend this application. So, for example, we can do things like send an email when a particular kind of fraud takes place. We also have built into the DataTorrent RTS platform alerting mechanisms so that you can send alerts to other operations-oriented systems to let you know about either a fraudulent transaction or if something worrisome is happening in the application itself. So a question about the dynamic rule updating mechanism. So the question is how does the dynamic rule updating mechanism work? Does it adapt to our data or the occurrences in our environment? So a couple of things there. So as I mentioned, usually there's two components to anti-fraud. So let me focus. There's rules, and then which are dynamic, and then there are also machine learning based algorithms. So let me talk about both. So in the rule engine part of our application, what happens there is you have the rule operator that's processing transactions at volume, and at any given time it's processing based on a set of rules. Those rules and the decision tables can be updated, and that rule engine can then be essentially reloaded without requiring any application downtime. So it's easy to extend the set of rules and then dynamically change the rule engine so that over time the set of rules that you're using to prevent fraud can be easily adapted. Now, in addition to that, the application can be extended to load a machine learning based model that maybe is trained on yesterday's data And so that machine learning model can also be used in parallel along with the rule engine to flag transactions as fraud and signal other downstream systems. So there was a question about the difference between stateful and stateless rules that we mentioned earlier. So a stateful rule is, very simply something where you have a rule that's based on some kind of period of time. So for example, you can't have a transaction within the last 5 minutes for a particular customer that's taking place in, California and in London and in New Delhi. Obviously, there's, that's a geographic problem, but you also have to look at, well, gee, you can't have all three of those happening within a 5-minute period. So the notion of state is keeping around state about where those transactions are taking place. So other kinds of stateful, transactions would be things that are sort of dependent on, data from, other previous transactions. So that's what we mean by state, is keeping some state information about previous transactions that have occurred, so that rules can be applied on, based on previous transactions we saw, a few seconds ago up to, minutes and potentially hours. So that's the difference between stateful and stateless. Stateless rules are, more like, something where you have a rule if something's over a particular volume and from a particular location and so forth. So they don't require a notion of time. You can evaluate a rule just based on that transaction at that point in time. There's a question here. So one of the questions is essentially, can you give some pointers to someone who's getting started in fraud analytics here? So, certainly one of the things, one of the pointers I would give is, take a look at our product and our application and better understand it. But if you are, part of an enterprise and you're a fraud analyst and you're trying to get started with understanding how this can be applied within your business, certainly one of the things you can do after today's webinar is, reach out to us. We're friendly people, happy to have a conversation with you and talk through how this application can be applied, within your enterprise. And I should point out that while what we're showing today is an omni-channel fraud prevention application, the basic pattern of taking in large amounts of data, events, transactions at scale, and passing that through a scalable rules engine is really the foundation for preventing a lot of different kinds of fraud and essentially making decisions in real time. So the entire application that I showed you, all of that data processing happens, in memory, and those decisions are made and events are emitted before anything ever lands on the hard drive. So this allows us to take in, hundreds of thousands of events a second and produce insight, in mere hundreds of milliseconds. And our platform and our product scales, so you just simply throw more computing at it as you have, more volume to process. All right, so I think the only other pointer I would give there, just looking at the question, is, again, looking at a lot of the fraud prevention applications that are out there. So the question was, can you give some pointers? As I mentioned earlier, towards the beginning of the presentation, there are a lot of very complete fraud detection applications out in the markets today. They're focused on some very important aspects of the problem, which is, the case management and all the various aspects that you need to, handle and manage incidents of fraud in your enterprise. Where we're focused at DataTorrent is on the hardest problem, which is, at the heart of any fraud prevention application, which is, can you handle the volume and produce the right outcome in a time frame that's going to matter? So the pointer I would give there is, while you look at what else is out there in the market, be very mindful about, is the technology underneath really solving the problem, and is it based on an architecture that's going to take you into the future and be flexible enough for you to be able to adapt it to all the different ways in which fraud is being committed today. Yeah, so there's another question sort of following on the same thing. So, it's easy to understand how this works with credit card transaction data. How could it work with insurance applications? So, the pattern, let me go back up here. So whether we're talking about a credit card transaction or some kind of request for service in an insurance application, it really comes, some kind of fraud happens in healthcare and insurance, all the time. Oops, sorry about that. What I was going to say is that it really comes down to the same basic pattern of taking in all of those insurance claims, being able to take that data in at volume with fault tolerance, and then be able to enrich that data with everything you know about that transaction from your historical data stores, and then be able to run those insurance claims through, again, same thing, a decision engine, which is typically a scalable rules engine plus potentially a machine learning trained model. But it's the same basic pattern, which is take in all the volume at scale, enrich it with everything you know about that particular transaction, and then pass it through a decision engine and make the best possible decision you can quickly about whether or not to flag a particular insurance claim as fraudulent or not. And so we're seeing across multiple industries this same pattern comes down to it's a different data, it's a different schema, but it's the same basic pattern for detecting and preventing something bad from happening. So with that, it looks like we're nearly at the end of our hour, and looks like the questions have stopped coming in, so I'm going to wrap things up there. So as far as next steps here for everyone, please do share your feedback. I think when we wrap up the webinar, there's going to be a very quick survey just asking for some feedback. We want to make sure these webinars are helpful for you. So please do give us your feedback either at the end of the webinar, or if you have to run off to another meeting, please follow up over email and let us know if this was helpful today. So we want to hear your feedback. And furthermore, we also would like to hear, what other topics you might want us to cover, how else can we help, and so forth. And of course, if we can help you in your organization, if you have further questions, please don't be shy, reach out to us. Happy to schedule a deeper dive where we can go into, more on the technology or the business side of how we work. So with that, thanks everybody. Really appreciate you spending the time today, and hope you have a great day.